In today's video, we're going to be talking about concave mirrors. And basically, after watching this video, you should just have a general understanding of the anatomy of a concave mirror. You're not going to have to do anything mathematical or draw ray diagrams yet. That's the next lesson. But for this lesson, we're just going to kind of talk about what a concave mirror is and the parts or the features of it. So let's get right into it. So in the previous lesson or lessons, we've been talking about these plane mirrors, basically flat mirrors. Now we're kind of switching directions here. There's two different types of spherical mirrors that we're going to discuss in this class. The first is called a concave mirror, and the second is called a convex mirror. And the way I kind of keep the two separate, because they both start with C and they both kind of sound similar, is concave. It's like you're looking into a cave. Okay, so this young lady here is in front of a concave mirror. It's kind of like she's looking into a cave, and it's bending this direction. Whereas a convex mirror are the kind that you might see at like gas stations or like Kohl's shopping store, where basically they have these mirrors and they're cameras really, and they look convex, that they bubble outwards. Okay? So we're talking about concave today. So I'm just showing you there's two different types. We'll talk about convex later on. So concave mirrors were silvered or kind of like have a glassy appearance on the inside of the sphere, whereas convex mirrors are silvered on the outside of the sphere, or they have a glassy appearance on the outside. Okay. So let's take a look at concave mirrors a little bit further, and what parts are a part of a concave mirror. In a concave mirror, there's something called the principal axis. And basically the principal axis, which you can see in this picture right here, is drawn right through the center of the mirror. Okay, so this line right here is the principal axis. Okay, and then along this line there's some points that are important to know. The first is the point in the center of the sphere from which the mirror was sliced is known as the center of curvature. Okay. This is also known as the radius. So if you think of the radius of a circle, it's half of its diameter. And this might not work out perfectly, but if I were to extend this circle outwards, you would notice that this is getting to be about like half of the circle where that center of curvature is right here. It's about half of the circle, and this is obviously, this drawing is really poor, but the center of curvature is where the radius would be, the distance from the edge of the circle to the center. Okay, and that's along the principal axis. The point on the mirror surface where the principal axis meets the mirror is called the vertex, which is this point right here, the vertex. Okay, and that's point A on this picture. Okay, so again, just kind of doing some vocab in this lesson, kind of learning the different parts of a concave mirror. So far, principal axis, center of curvature, and vertex. Let's take a little further look at some other points on a concave mirror. The midway point between the vertex and the center of curvature, so between point A and point C, is this point called the focal point. And this is something we're going to be using a lot. So have an idea where the focal point is, because it's important. The focal point is typically represented with an F. Okay? The distance from the vertex to the center of curvature is the radius of curvature, which I kind of talked about in the previous slide, where again, this is the radius of the circle. Okay? The distance from the mirror to the focal point, or to F, is called the focal length. So sometimes you'll see C as 2F, and the reason why you'll see it as 2F is because basically it's two focal lengths. The radius is going to be twice as much as the one focal length. Okay. So let's keep moving right along. The focal point, and again, that's why it's such an important feature on mirrors, is where light will meet after reflecting off of a concave mirror. So this picture looks really like a lot of stuff's going on, and there is, but these blue lines, the blue lines are the incident rays, And basically these are coming off an object or a light bulb or whatever the case may be, wherever these light rays are coming from. They hit this concave mirror, and then every single reflected ray, which is represented by red, is going to travel through this center point called the focal point. Okay? And that's true for all concave mirrors. This focal point is where all the reflected light waves will eventually meet. Now, just a recap on the law of reflection. Right? This law still stands true, even though these mirrors now have a curve to them. It still holds true that basically light will always follow this law of reflection, where the angle at which the light hits the mirror will equal the angle at which it reflects off the mirror. Okay, and you can draw that normal line, which is perpendicular to the mirror. And what's kind of cool about concave mirrors is that normal line, which is represented by this dotted line here, will extend through the center of curvature, no matter where you are on the mirror. Something like if I were to draw one here, and I wish I could use like a ruler tool, but this line, this normal line, and again, I'm not doing it straight, would have gone through the center of curvature, and you can see how bad that is not straight. I apologize, but should have gone through the center of curvature. Okay, so if that's helpful to you, feel free to draw those normal lines when you're drawing these ray diagrams. So just something we're going to get into in the next lesson is drawing ray diagrams. Okay, so drawing the normal kind of helps you to see where the reflected light rays go. So in the previous lesson, we talked about how images can be formed in plane mirrors, okay, or mirrors that are flat. Okay, concave mirrors are also able to form images, and what's kind of interesting is plane mirrors only formed virtual images. That basically meant that the image was formed on the back side of the mirror where the light could not go. Concave mirrors are able to form virtual and real images. So here's an example of a real image. You've got this object, whatever it is. For right now it's just a ball. And basically you have light reflecting off the ball, or well, I should call it incident rays, coming off the ball, hitting the concave mirror, right? And it's forming an image right here, okay? And so these light rays are on the left side of the mirror, on the same side as the object, and so that's called a real image. This is an example of a real image, when you have the light waves or light rays all meeting at one point on the same side as the object, okay? And this object has been placed behind the center of curvature, and we'll talk more about that later on. Basically, the object's placement in front of these mirrors is going to tell you a whole bunch of things, and we're going to make a chart in class, so don't worry. Here's just another example. Now the object has been placed between the center of curvature and the focal point. Okay, and so here's the object, and the image location is way back here. Now, is that a real or a virtual image? Well, it's on the same side as the mirror, so it is a real image. It's not virtual, it's a real image. And I actually don't have an example of a virtual image, but virtual images for concave mirrors will form anytime that you're on the right side of the focal point. So if I put an object here, you would get a virtual image on the other side of the mirror. So that takes care of this lesson. I will see you guys next time.